So, the fundamental theorem, algebra. Sounds so deep. It's not. So, every polynomial equation with a degree greater than 0, so that it's not like y equals 7 or something like that, has at least one root. One root, one x-intercept, one answer. So, we are going to find all the zeros, or all the solutions here. So this is a real good outline on 1 through 4 on the easiest way to do this. So first we're going to use the graphing calculator to find any easy x-intercepts. We're always hoping that we find all of them. That will happen every once in a while. So we do that first. Then we do synthetic division if we still have to find some. And then we're going to repeat. Yes, we may have to do synthetic division more than once in a problem until we reduce the polynomial to a quadratic. Once you do your synthetic division and you fill the variables back in and x squared is the largest one you have, you're done with your synthetic division. Now we're going to factor or use the quadratic formula to find the rest. Sometimes you're going to have a choice, sometimes you're not. If factoring doesn't work, that is the option, because I'm going to be looking for exact answers. So no, you cannot just go looking around on the calculator, and some of your answers are going to be imaginary. So we're going to see the eyeball some today too. So you will get the same number of solutions as the degree. It just depends how many are real, how many are complex, and you may have some double roots. So here we go. Now, on the you must show work, we'll chat about that as we get into these. So, step numero uno says use the graphing calculator, so that's what we're going to do. Well, it depends on what the solutions and the solution types are. Let me explain. So I get this first one, I pull it up, and I'm hoping to see, I might see exactly what I wanted here. Wait a minute. I might have all three off the graph. Let's check this out. What am I looking for? I'm looking for, remember, what x-intercepts occur when y equals 0. So if I'm using the chart or my graph, what I'm doing is I'm staring down and I'm hoping to see as many zeros in the y column as I can, because the x value is an answer. Ooh, there's one. Oh, now see, this is like the perfect problem. Because I'm supposed to get 3 answers. I got 3 answers right off my graph. Your work for that is, I got all of them off the graph. Okay? Is this going to happen often? No. No. Will you get 1 or 2 normally? Yeah. But you're not going to get all of them. So I like to kind of put that out there that you could, but don't think that's gonna happen a lot, because it's not. Okay, let's get into back to reality here for a moment. 2. All right, let's see what we get this time. Well, that was cool, Hardy. I see like 1 line. Okay, that's all we need. I see my 0 there. It looks like it's at 1, but let's check. It is at 1. Okay. So we got x equals 1 from the graph, but we need 3 roots. We only have 1. So this time we get to go to step 2. This x equals 1 is not a factor, it's a solution. Do not change the sign if you have x equals in just a number. 3, 2, 1, 0. Yes, we still need to look for gaps. We don't have any this time, though. So here comes the synthetic division. Bring the first term down. Multiply by what's in the box. Add down.
multiply, add down, multiply, and add down. So, two things to mention here. Number one, I should have gotten 0 here on the end because this is a factor. Well, not a factor, it's a solution. So if I didn't get 0, something went wrong. Number two thing, hip hip hurrah, I didn't make a mistake through the first problem. Yay. And then finally, and I heard it mentioned, when I go to put my variables back in, we start 1 degree less. And I notice it's x squared. It's a quadratic. So biggest thing to mention here is that this is not a difference of squares. Do not try to factor it that way. We're going to solve this one by roots. So we're going to minus the 49 over. We're going to square root this. Two things you have to remember. When you get to the square root step, you auto go to plus minus to get your two answers. And it already got mentioned. Make sure you pull an I out. So I square root of 49, the square root of 49 is 7. Positive 7i, negative 7i, x equals 1. There's your three answers. And you're done. So that's the part of this that gets a little more interesting. Well, let's see. Let's get a bigger one going. Let's do 4. Okay, let's do 4. Let's give 4 a run. All right, let's see. X to the 4th. Ooh, we get 4 answers this time. All right. What's that? I should freeze frame this one? I don't know. I do want to freeze frame one today. I haven't done that in a while, so. Oh. Do we get any more? No? What's it look like here? Negative 1, 2, 3, 4. Negative 1, negative 5. Let's see. Negative 1, negative 5. Okay, but there's 4 answers. So, the question usually comes up here now, well, which one do I use for the synthetic? Doesn't matter. You use either one. Because, I'll give you a hint, we're going to use both of them anyway. So, you roll with either one. I'm going to roll with negative 1 first. 3, 4, 3, 2, 1, 0. No gaps, hot dog. Make sure we get all of our coefficients ready to go here. I'm going to write a little smaller. Pull that first term down. Multiply by what's in the box. Add down. Multiply what's in the box. Add down. Multiply by what's in the box. Add down. In the moment of truth, there's our 0. That's good. This time we'd started with a 4th degree polynomial. 3, 2, 1, 0. And as you so eloquently just mentioned, until this is a quadratic, it is a cubic right now, we have to do synthetic again with the one that we did not use before. So if you use negative 5 the first time, you would use negative 1 the first time. We're going to end up in the same place. It's kind of amazing. But remember, this is the polynomial you're dividing by now, okay? This one, not the original, because otherwise we're not getting down to a quadratic. 3, 2, 1, 0. So 1, 5, 9, 45. First term on down. Multiply, add, multiply, and add. Okay. Got the 0 again. X squared, because now we're going down 1 from this one. X, my constant. Now we are down to a quadratic. So now we can play all the games. Again, on the square root step, plus minus. Since there is a negative, make sure to get your I pulled out. 1, 2, 3, 4 answers. Now again, your quadratic could end up being factorable, or it could end up needing to use the quadratic formula. It's not just going to be solved by roots every time. Yes, I absolutely am still going to make you use the quadratic formula sometimes, yes. No. Well, you better figure it out. You got, how long you got to figure this out? Because you might need it on the exam too. So yeah, you got a couple days to figure this out. So we're going to be all right. All right, let me think. Okay, I think I found our weird exception. Let's try. Number 6. Oh, number 6. Oh, let's see what we got. Well, hang on. Let's see what happens here. Let's see what happens here with 6. Oh. We got 2. Okay, let's see. There they are, -4, -2. All right. So, who wants to rattle off my numbers that I'm using for synthetic division here? Go for it.
1, 0, -18, 12, 8, 2, 0.
Man, iron trap right there. Nothing gets by him. Okay. We had a missing term at x to the third, so we got to have a 0 in there. If we miss the 0, oh geez, we got to go like all the way back. That's no fun. So okay, let's see where else this gets us here. Multiply and add. Multiply and add. Multiply. Okay, step 1, good. We got the 0. Unfortunately, we noticed that that was a 4th. Was a quartic. Bust out some vocab here. So, we do have to go back in again. So, again, running on this one. Now this time there are no gaps. That was nice. You could. I just like putting it in because then it reminds me I have to do it again. So I don't think, oh, I'm done. Yay! And then I'm like, oh, no, I'm not. So multiply and add. Multiply and add. Multiply and add. Oh, did I do it? I think I did. So we've got x squared minus 6x plus 10. Definitely not solving by roots this time. Is that factorable? Not really. It is not factorable. What factors multiply to 10 and get me to 6? Wherever it came from, it is not factorable. So, yes, quadratic formula, here we come.
Bro,
opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Let's go. So, as we have mentioned multiple times, I will mention it again here. If you are going to use a calculator on this part, don't put it under the radicals. Just put the stuff underneath, because we're doing exact answers. So let's see here. 36 minus 40. Oh boy. So, let's see here. Negative 4. Square root of 4 is 2, but again, you got to pull an eye out because of the negative. And, my gosh, and since all three of my coefficients are divisible by 2, we need to make sure we get this all the way down to get my 4 answers. Probably for most of you, that would be the nastiest thing you could see. Because any factoring is just going to be a regular multiply this and add to this. It's not going to be like a slide and divide or anything. So, but that's kind of the options we're playing with. So now, first, questions on any of the steps we've been doing. Because I got one last thing. Okay. The one last thing is, as we normally do in here with everything else, here we are finding the roots and stuff. Now you're going to be given the root, you're going to be given the zeros. We got to turn it back into the polynomial. So we're going to go backwards. Now we're not going to like do synthetic division backwards. That'd be kind of weird and crazy. Not going to go there. But what we're going to do here is write a polynomial function of least degree, bless you, that has the given zeros with integral coefficients. Okay, here's what that means in English. Here's the answers. 2, 1, and 4. Let's work this backwards. Actually, let's do it like this. So I got x equals 2, x equals 1, x equals 4. After the first one, I wouldn't suggest you have to do this, but for this one, we will. Now think about the set of parentheses or the mini equation you would have to get to have that solution. In other words, we're going to flip signs on all of these. Because what I want you to think about with this, if I set x minus 2 equal to 0, I'd get x equals 2. If I set that equal to 0, I'd get x equals 1. If I set that equal to 0, I'd get x equals 4. So here are the factors. Okay, these are the solutions. These are the factors. We're working backwards. Now we got to multiply the factors out to get the polynomial. So, unless it says write it in factored form, this would be factored form. But it doesn't, so here we go. Multiply them a pair at a time. Do not try and be a hero and do this all at once. It'll be a mess. It'll go bad. So, x squared minus 2x and minus 1x would be minus 3x plus 2. We're getting there. One more time. So now, again, you could distribute your x through maybe. Just tack an x onto each of those. And then the minus 4, distribute that through. Don't leave it like this. We still have like terms we can put together. And that, ladies and gentlemen, would be a polynomial, a cubic, because it has 3 answers of least degree for those particular zeros. Now, again, I'm not going to put you through that a whole nother one. All I'm going to write for number 8, just as a reminder, if your zeros are negative, It just means these are all going to be plus. No, I'm not making you do it again. I'll make a little note here, multiply out, so you don't think, oh, that's just the answer. No, it is not just the answer. We'd still have to work that through. So here's the twist on this. You're like, well, this isn't bad. You can have imaginary solutions with these complex numbers, I. And when you get an I as one of your zeros, you get a bonus with it every time. You get its complex conjugate pair. So here's what that means in English. Okay. See, may leave in factored form with integer coefficients. Hallelujah that we get to do that. Okay. So zeros of 8 and I. You're like, okay. So if that's 8, okay, so that'd be negative 8. To remind us of this imaginary solution, so check this out. X minus I, when you have I as one of your zeros, oops, hang on. You get negative I as a bonus. You get the opposite. And since it says we may leave in factored form, then we're just going to leave it in factored form because it says we can. Yes. So if we do that here, x plus 5, okay. Now, this is the part that gets a little more koofy. These are bonded together, this 3 plus 2i. So you're like, wait, how does that work? X minus, we're going to fix this up in a minute. Because again, we're doing opposites. So I'm doing the opposite of that 0. Bracket versus parenthesis wouldn't matter in this case, since we're not doing interval notation. If you're more comfortable using a different sign and not having parentheses and parentheses, that's okay. Nope. There's my complex conjugate pair. You're just changing the sign on the I. Just like when we were trying to get fractions that had I and we wanted to get the I out of there, we multiplied by a complex conjugate. So here, x, whoops, I almost did plus. Hang on, that is a minus. Minus. Now, we're not going to leave it that way. We're going to clean this up. We're not going to multiply it out, but we are going to clean it up. Yeah. So here, x minus 3 minus 2i. Because again, we're just distributing. It's nothing. Because we need to make sure that minus goes to both terms and not just the first one. So anytime there's I, always got to remind myself, hey, there's a bonus that I'm not seeing here. It's there, though, because otherwise things would go bad for us. And again, these last two, it's the same stuff. I'm not going to do all the same stuff again because we've already played with that. So, I'm done. So big picture again. We always have to think about the big picture here. So today, we are dealing with page 7 and 8. You know the drill. Odds or evens. Odds are on there. Evens are up here. Just so you don't think about this later and email me or ask, we are not doing 9 and 10. But if you have not started looking at the preview yet, you're going to want to because it's a chunker. Oh, no, I've looked at it already. I've done 2 review videos and a key for it. I've looked at it. This first